Okay, for number 8 on our transformation, we've got this original given as 2x minus 4. Okay, so the f of x is again 2x minus 4. So when x is negative 1, all right, I plug in negative 1 for x and I go and do a little bit of mental arithmetic. Or I can see at my graph negative 1 down here at negative 6. Either way I do that, I still get negative 6. 0 is at 0, negative 4. 2 is at 2, comma 0. 4 is at 4, comma 4, comma 4. And 5 is up here at 5, comma 6. Now, for g of x, I take a look right here at my directions, and I want to go up 6. So I want to take all those y values and go up 6. So negative 6 plus 6 equals 0. Negative 4 plus 6 is 2. 0 plus 6 is 6. 4 plus 6 is 10. And 6 plus 6 is 12. So those are my changes. Okay, so you're going to take this original and move up 6 units. Now, the problem with that is the points that I have highlighted are going to go off the graph. So take the points that you can on the original and move it up 6 units. So if I go down here, back at that negative 6, move it up 6. Up 6 puts me at negative 1, comma 0. Negative 4 up 6 puts me at 0, comma 2. Right here at 2, comma 0, go up 6, I'm here at 2, comma 6. And that's as best as I can do. Take your ID and make your line. And what you should notice is these lines are parallel, are pretty darn close to it, because all we did was move it up 6. So we said we translated up 6 units. The transformation function then is taking the original and going up 6. Now the original happened to be 2x minus 4. These are like terms. So the transformation one is negative 4 plus 6, which is 2x plus 2. So g of x is 2x plus 2. All we did was take the original and went up 6 units. On number 9, we can see that there is a half times x. So we say it is a vertical dilation by a factor of a half. So that's going to change my slope. It's not going to be as steep as the original. It's going to decrease a bit. Now, crap. Sorry, I looked at the wrong thing. It's a vertical dilation, but a dilation of 6. Sorry, my original was 1/2. My transformation says 6 times the original. So it's actually going to get more steep. It's going to go from increasing to increasing very quickly. So multiply it by a factor of 6. It starts off as a half. So I'm going to say what is 1/2 times 6, which is 3. So it's going to increase more quickly than the original by a factor of 6. So b of x equals 3x. On letter B, this is my original again. Now, when I look at what's happening to the transformation one, all I see is a minus 1. So that is going to be translated down 1 unit. So then I'm going to go ahead and take the original and say that. I'm going to subtract 1, and the transformed one will be 3x plus 2. And number 10, do exactly what it says. You've got the original here as 2x. And on letter A, we want to take the original and add 6 to it. So we're going to take that and translate it up 6 units. Now the problem with that is I'm going to go off the graph, so I'll just pick some of those choke points nicely. I just need to pick 2 points to follow. So here's a nice point right there. And I'm going to go follow, say, these 2 points, okay? I'm going to go with these 3 points. So I'm going to take these 3 points and just kind of follow them by going up 6. So the first one here goes up 6. Go up 6 here, takes me to 4. The next one goes up here to 6, and this one goes up here to 8. Take your ID, line it up, and that is going to be my f of, nope, that is g of x. Okay. Then for the next one, we want to go to f of x. So that means take the original and multiply the y values by 2. It's a vertical dilation. So I'm going to say vertical dilation by a factor of 2. So I'm going to take the y values and multiply by 2. So go back to those purple ones to start off with. It's at -2. -2 times 2 is -4. 0 times 0 times 2 is still 0. And for the other one, I'm at 2. 2 times 2 is 4. And there it is. It stretches that out. Take your ID. Line up those 3 points. And this will be my h of x. Okay. And I'm going to go back and say that this one was translated up 6. Okay, we get a different color. We go orange. For letter C means it was reflected over x-axis. So it's increasing at the moment, and then it's about to be decreasing. So all my y values are going to change signs. So let's go back and do that. Okay, so I'm going to follow those 3 original purple points. The y values are going to change signs. So it's at -2, and then it's going to be at +2. It's at 0, stays 0. And if it's at +2, it's going to become down to -2. Take your ID, line up those 3 points. And this one is called j of x. And then lastly, let me go with the blue. Okay, this one has 2 things occurring. It's got a translated up 1, and then it has a vertical dilation by a factor of 2. So to do that, I'm going to multiply the y values by 2, all right, and then add 1, then move it up 1. So let's go back to those purple ones and do that. Okay, so I'm at -2, that first purple one. Multiply that by 2, that takes me down -4. But then I'm going to move it up 1 because of +1. 0, right there in the middle, times 2 is still 0, but I'm going to move it up 1. And then I'm up there at 2. 2 times 2 is 4. 4 plus 1, move it up 1. And then, 4. 4 up 1, that's up 5. Okay, 2 times 2 is 4. 4 plus 1 is 5. Take your ID, make your line. It's that blue line, which is then h of x. Okay, get Mathia done through Unit 5.